And I'm going for something a little bit more generic than molecules, because you could have atoms here and then have to go to molecules later. So this is moles of A. You can convert that into particles of A. And from particles of A, you can convert that into particles of B. So this would be a 1-2 step process, yes? So for example, if we are asked how many O atoms, that is our unknown, what are we starting with? What is our initial quantity? 3 moles of sodium phosphate. So the first thing you need to do is you need to write the correct formula for sodium phosphate. Could you all please do that? Sodium phosphate. So sodium phosphate, Na3PO4. So we are starting with the moles of sodium phosphate, which means we are starting over here, yes? We have moles of substance A, and in this case, A is sodium phosphate. For moles of sodium phosphate, you can use Avogadro's number, 6.02 times 10 to the 23, to convert to particles of sodium phosphate. Sodium phosphate, I'm going to color code it green here. Okay, so we go from moles of sodium phosphate to the number of sodium phosphates using Avogadro's number. And then from particles of type A, we go to particles of type B. How do we convert from one type of particle to another type of particle? We use what do we use to convert from one type of particle to another type of particle? Particle ratio. And where do you find that? You have to count the ions or atoms in the chemical formula. And while you are starting out on this journey, feel free to have your yellow sheet out in front of you, although I've sort of cribbed for you a little bit in that I've put this at the top of every page, okay? So how would you set this up then? You would say, I want to know how many oxygen atoms, and I'm starting with 3.000 moles of Na3PO4. If I then want to find the number of Na3PO4, remember I have to write times and then a line. What unit should go on the bottom? Moles of Na3PO4. And what should go on the top? Formula units, or molecules if you prefer, of Na3PO4. Now you have a choice here. You get to write 6.02 times 10 to the 23 either beside the formula unit or beside the mole. Where does 6.02 times 10 to the 23 go? Does it go with the mole, or does it go with the formula unit? Tell your partner what you think. Shall we vote? Okay, you're going to vote A if 6.02 times 10 to the 23 goes with the mole, and you're going to vote B if it goes with the formula unit. 5, 4, 3, 2, go. And it's okay if you don't know. Yeah, lots of B's, couple A's. All right, it is B. It does go with the formula unit. And if you have trouble remembering that, we're going to take our little song. Do you remember? The one goes with the prefix. The one goes with the prefix. And we're just going to put the word mole instead of prefix. So it's not as nice of a song, but then I didn't have to make up a new song. And I'm not actually that creative. So the one goes with the mole. The one goes with the mole. Everyone. The one goes with the mole. The one goes with the mole. Do the hand motions too. The one goes with the mole. 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 And the more you actually do it out loud, the more you will remember that on a test or quiz. Should we do it one more time? I want to hear from you. I want to hear from all of you. At least a little bit. And even if you're just like, it's all good. Okay, the one goes with the mole. 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 Excellent. All right. And this is actually going to be true whether we are using Avogadro's number or whether we are using molar mass. The one goes with the mole. Okay. So one goes with the mole, and we have 6.02 times 10 to the 23 formula units. Are we done the problem? No, because we didn't want Na3PO4. We wanted oxygen atoms. So we're going from one type of particle to another type of particle. What do we use to go from one particle to another particle? Oh my God, you guys are killing me. To go from particle A to particle B, what do we use? The particle ratio. Where do we get that from? Tell your partner where we get that from. Where do we get the particle ratio from? We get it from the formula of the compound. So you would need to have the correct formula of the compound written out, and then you would have it there. So right now we have formula units of Na3PO4 on the top. We need to cancel that out. So formula units of Na3PO4. And what are we being asked for? O atoms. So we're being asked for O atoms. So that goes on the top. How many O atoms in an Na3PO4? Super hard. There are 4. Just count them up. Okay, we do our math on that. And we get 3 times 6.02 times 10 to the 23 times 4 equals 7.224 times 10 to the 24. Is that a good answer?
No.
No, what have I forgotten? Sig figs. So let's take a look. 3.000 has how many sig figs? 4 sig figs. 6.02 times 10 to the 23 has how many sig figs? 3 sig figs, because that number actually has a lot more digits in it. We've just rounded off. Okay, I forget what it is, but it's like 6.022 blah, 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 blah. Okay, so this has 3 sig figs. How many sig figs in the 1 mole? It's an exact number, therefore infinite sig figs. And how about our 4 and our 1? Are there approximately 4 O atoms? No, there are exactly 4 O atoms, therefore it has infinite sig figs, and that's in exactly 1 formula unit, so there are infinite sig figs. So our answer should have 3 sig figs, 7.22 times 10 to the 24, and I'm done, right?
No.
Not just atoms, but O atoms. Okay, so don't forget your unit at the end also. Okay, let's actually, oh, here we go. This is a good one. How many moles of dinitrogen tetroxide atoms? So this is number 3. We're going to do it together. How many moles of dinitrogen tetroxide molecules can you make from 1.204 times 10 to the 24 oxygen atoms? And I just put and enough of everything else just so you know you've got lots of the other stuff. What are we starting with?
Calculator. Thank
There you go. What are we starting with? One 1.204 times 10 to the 24 O atoms. 1.204 times 10 to the 24 O atoms. And we are wondering how many moles of, what is dinitrogen tetroxide? What's the formula for that? N2O4. Can I do this in one step? Is there any way to go from particles of O to moles of N2O4? Remember, this is A, and this is particle B. So we have 2 different types of particles. Can I go from the number of particles A to the moles of particle B in one step? No. What do I need to change O atoms into? O atoms need to get converted into, eventually I want to end up with moles of N2O4. Tell your partner, what could we go from O atoms to in order to get to moles of N2O4? And if you're not chatting it over with your partner, You should be. Is that a hand or a stretch? That's a stretch. Okay, if we go up here, we can say, oh, I have O atoms. I could convert that into N2O4 molecules, and then I could convert that into moles of N2O4. Yes? So if you get stuck, you can look up at the top of the page for now. That's not always going to be there, so make sure you're trying to think it through before you look at that little map at the top. So if I want to cancel O atoms, where do they go? On the bottom, so we need N2O4 molecules. So O atoms go on the bottom. N2O4 molecules go on the top. What number goes on the top? 1. How many O atoms are in one N2O4? Everyone. 4. That was easy. And now I want to go from molecules to moles. What do we use to go between particles and moles? It's going to be an Amber Alert or something like that, right? Oh, it's a test of the National Public Alerting System. Okay, it works. So, molecules. That's going to be irritating down in the AP exams. Holy cow. All right, what goes on the bottom? N2O4 molecules. And what goes on the top? Moles of N2O4. And what number are we going to use in here? Between moles and molecules, we use whose number? Avogadro's number. And what is Avogadro's number? Say it out loud so you remember it. 6.02 times 10 to the 23. Remember, it's as easy as 1, 2, 3, 10 to the 23. Okay, and where does the 10 to the 23 go? 6.02 times 10 to the 23. It goes with the particles. 6.02 times 10 to the 23 particles, because the 1 goes with the mole. Yes? We chuck that in our calculator. And we get 1.204 times 10 to the 24 divided by 4 divided by 6.0223 equals 0.5 moles. Are you happy with my answer? No. What are you unhappy with? Sig figs. How many here? In the 1.204? 4 sig figs. How many in the 1 and the 4? Infinite sig figs, because we don't have approximately one molecule. We have exactly one molecule, and which contains exactly 4 O atoms. So infinite. And then how about this 1 mole? That is infinite. And what about the 6.02? 3 sig figs. Okay, so we need 3 sig figs. How many zeros should I put on the end? 2. Am I good now? No, because I'm working with 2 different types of particles. So you need to tell me which one. Okay, so it needs to be moles of N2O4. Is good? Okay, you guys are going to practice these. And in about 20 minutes, I'm going to interrupt you and make sure you can do something new. So just start working through pages 21, 22, and 23. And if you get bored with that, you can start working ahead on pages 45 and 46. That's the other thing that's going to be for homework. Hi. Okay, let me just turn on the lights and stuff, and then I'll come help you with that. Okay. Help yourself.
Maxing out, dude. Maxing out. Close. Actually, through that. I should just retire, play classified. That'd be ideal. No, they don't. She didn't. Yeah. Yes. Okay, so we can use that as a template. Yeah. So when you have that out. Starting with the seven lines. And you're going to multiply by. You're coming out. You're going. Oh, yeah. And then the ground, yeah, you can, yeah.
Good actually, here by that.
Okay.
How do you land?
Yeah. Yeah, does that make sense now? Cool, and so you'll find a little massive or the molten water doesn't. Hello. Yeah. Yeah. Okay. So, the other report is, so we found magnesium chloride mold. Yeah. Yes. Okay. We want chlorine. Yes. Okay. Absolutely. The only thing here is that ClO3 geometry have your formula. So three is negative one. And magnesium is two plus. So that'll affect your answer. You have to balance that and that'll change.
Let's restart. You know, I got this from. One ball here. We got back to class plan break. I don't know what accent. Yeah.
Yeah.
Supposed to be.
Yeah.
Oh, I think that, and we're something. Yeah. Yeah, that's good.
And we're starting with that.
Okay, first. Yeah, I get my war attack in. It's a rush guy. This should be easy.
Or formula, whatever you. You, I mean, technically it is formula. Yeah. Yeah, yeah.
Okay.
This is a mountain. So how many? Well, we gotta do that. It's like, yeah. Okay. Yeah. Started and, Going. Good. Uh-huh. Yeah, because you've got this there. Right. It is the only name you're part of it. Right? Here's some high. Oh, yes. Yes. Okay. So that's going to be a convertible. Yes, you'll end up with this. So you're going to say, I have open ability walls times that. Now you want and you see on the three, two, sorry, that see on the three minus. Yeah. Yeah. So you'll get from wall. Come here. Then. We don't want to. What are you doing?
I guess it's one with hours.
Of course. They're going to use numbers out of it. How to be Oh, so.
No. I really got
Right? Does that make sense that we have 650 billion sulfides for every one sulfides? No, that's what he's saying. I told them that's what I'm going to go back. Right? Okay. So what you have is you want to go back. We started here this time. Okay, that's what I do. Go from atoms to formula units. And the formula unit is what was. The formula unit is big. Yeah. So if you want to know. Yeah. And now what you're gonna do is you're gonna say, now I have particle, now I have the whole. Now where I'm gonna do that boundary. You know what I mean, like that, we're saying I have. You know, yeah, exactly. So. No, and we cancel and. Two. And particles. Moles of. Great. And if we're looking out from the moles. It's not that one. Yes. Yes. Okay. Right. Mm-hmm. Yeah. He's referring back to your, I did that here. Okay. See. Yeah. Right. Yeah. Yeah, exactly. Pat? No, the message tomorrow is just on the pharmacy and. Okay, close tomorrow's quiz slash test slash whatever it is, just on chromatography and hydrate, so make sure you've done that review that I gave you guys. Okay, nothing on the wall on that quiz, okay, from that. Yes. Because we're swapping around between different. It's okay to do this. I'm one whole, it's like saying one dozen donuts. That's fine, and you realize, those are the exact things, and not exactly. Right? And that's why I keep writing, so that you finish. And
Ready for level class? Coming up soon. Yeah. Ready? Same. Don't worry, we'll get through it. I rather.
yeah. Yeah. So here we go.
I have no idea.
Up page 23 and then 45. That's kind of my part.
Sorry for that, bro. Glad you graduated next year.
How you doing, Scott?
Great.
Excellent.
Yeah. Good. I'll click you excited. God, well, you know, finish the job for my years. Then you get it out there.